Welcome back to the deep dive. Today, we're conducting a bit of a security audit on your daily life. I just want you to picture your work laptop.
Okay.
When it's sitting on your desk at the office, it's docked, plugged into the Ethernet. It's safe, it's comfortable.
It's living in the fortress. I mean, the perimeter is physical. You've got guards at the door, you've got badge access, digital firewalls that are 10 miles high.
Exactly. But here's the reality for pretty much everyone listening. That laptop doesn't stay there.
No.
You unplug it, you throw it in a bag, you go to an airport, you open it up at a coffee
You
shop,
connect to your home Wi-Fi.
and the second you leave that building,
Yeah.
that laptop is wandering through the Wild West.
And that is the defining headache for modern IT. The perimeter isn't a building anymore. The perimeter is wherever that user happens to be.
So the question we're really wrestling with today is,
Yeah.
how do you keep that castle security when the castle walls are, gone? How do you secure a device that's constantly jumping between a high-security corporate network
Yeah.
and, say, the public Wi-Fi at a Starbucks?
It's the classic mobility problem. If
Yeah.
you lock the device down too tight, treat it like it's in a war zone 24/7, the user can't do their job.
Right. They can't print, they can't share files.
But if you leave it too open, you get infected at the coffee shop, and then you bring that infection right back into the office.
So to solve this, we're digging into a concept called location awareness. We've pulled together a whole stack of sources for this one.
Yeah, we have.
Technical manuals for Symantec Endpoint protection, some surprisingly heated troubleshooting threads from admin forums, and a fascinating set of guides from a group called Watchpost Security.
And the mission for this deep dive is, well, it's really specific. We're not just talking about firewalls in general. We want to understand location switching.
Okay.
How do we turn a laptop into a chameleon?
A chameleon. I like that image.
That's really what it is. You want the device to instinctively know its environment and then change its skin, its security armor, automatically just to survive.
So if it's in a hostile environment, the scales go up.
And if it's safe, the scales go down.
Okay, but let me play devil's advocate for a second. Why do we need the scales to go down? Why not just leave the armor on all the time?
You could do that.
Lock it down to maximum security, block every port, and just keep it that way.
And from a pure security standpoint, that sounds great. But practically, it's a nightmare. See, inside the corporate moat, you need some openness.
You need to talk to the printer down the hall.
You need access to shared drives on the server. You need your computer to say hello to other computers, to, manage updates.
Right, collaboration requires open doors.
Precisely. But if you take that same open posture and walk into a hotel lobby, those open doors aren't for collaboration anymore.
There are vulnerabilities.
They are kick me signs just waiting for someone to walk in.
So the laptop needs to be context aware.
It has to continuously ask, where am I? And based on that answer, corporate LAN, VPN, or public internet, it switches to a specific location profile with a whole set of rules.
The Watchpost security documents had a phrase that I underlined that I think sums this up perfectly. It said, secure your perimeter, wherever it may be.
That's the philosophy. It's not about defending the building anymore. It's about crafting a defensive posture that travels with the user.
Okay, let's get into the gears of this then. The source material breaks this all down into 3 critical scenarios.
The 3 skins of the chameleon, you could say.
Let's start with the scariest one first.
The public user.
Scenario 1. I'm at the coffee shop. I've got my latte, I have my laptop, and no VPN. I'm just on the raw, unfiltered internet.
This is the danger zone. And in the Symantec logic, and really in any security logic, this should actually be your default location.
Why default? Shouldn't the default be the office?
No, because of the fail-safe principle. If the computer gets confused, if the software crashes, or if it just doesn't know where it is.
It should assume it's in danger.
Yes. Guilty until proven innocent. If you default to the office setting, you might accidentally leave your shields down in an airport.
That makes a lot of sense. Assume the worst. So what does the armor actually look like here? The sources were very specific about blocking something called NetBIOS.
Oh yeah, NetBIOS is the big one. We're talking specifically about TCP ports 135, 139, and 445.
Okay, hold on. For those of us who don't memorize port numbers for fun, what are these actually doing? Why are they the villain here?
Think of them as the neighborly ports. They're designed for file sharing and network probing.
Okay.
On a trusted network, they help your computer find the file server or the printer. They shout out, "Hey, I'm here. Does anyone have files for me?"
Which is polite in the office.
It's polite and necessary in the office. It is catastrophic in a coffee shop.
Right.
On public Wi-Fi, having port 445 open is essentially unlocking your front door and shouting your address. It allows anyone on that same open network to probe your machine.
So the strategy for scenario 1 is pretty simple. Silence them.
Explicitly block all local TCP traffic on those ports. Bolt the doors shut. You want your computer to be invisible to the rest of the coffee shop.
Now, what about updates? If I'm at the coffee shop for 4 hours, my computer still needs to get new virus definitions. But if I'm blocked from the corporate network, how does that work?
That's a crucial catch. Usually, your computer tries to ask the internal company server, the mothership, for updates.
But it can't reach it.
It can't reach the mothership from the coffee shop, so if you don't change the setting, it'll just keep trying and failing and you'll be vulnerable.
So you have to reroute it.
Right. For this public location policy, you configure the live update settings to just bypass the corporate hierarchy. You tell the client, don't look for the internal server. Go directly to the public internet. Go to the Symantec source.
There was one other setting mentioned for this high-risk zone regarding the scanners. Truscan and Sonar.
Yes, these are the heuristics engines. So this isn't just checking a list of known bad files. This is looking for suspicious behavior.
Like what?
Is a program trying to record your keystrokes? Is it trying to dial out to, I don't know, Russia?
And in the coffee shop, we don't take chances.
Exactly. In the public scenario, you crank the dial to 11, you set sensitivity to high for Trojans and worms, and the action isn't just log it and tell me later. It is.
Quarantine or terminate. No mercy.
No mercy.
Okay, so that's the public scenario. Full armor. Now, let's look at scenario 2. This is where I think a lot of people, myself included, get a false sense of security.
The remote user on VPN.
Exactly.
This is the tricky one. You're sitting at home, you've launched your VPN client, you see that little lock icon turn green.
I feel safe. I feel like I'm back inside the fortress.
But you're not entirely. You're in a secure tunnel connected to the fortress. But the risk here is something called split tunneling.
I hear this term thrown around all the time. Split tunneling. Break it down for me. What is physically happening to the traffic?
Imagine your laptop has 2 cables coming out of it. One cable goes into the secure VPN tunnel, specifically to talk to the office servers. The other cable, it still plugs straight into your home internet provider to watch YouTube or whatever.
So I have a secure line and an insecure line active at the exact same time.
Exactly. And here's the nightmare. Malware from the insecure side, say, from your kid's iPad on the same home, Wi-Fi can hop onto your laptop.
And then ride the VPN tunnel straight into the corporate office.
It bypasses the main castle gates completely. It's a backdoor.
Wow.
It's a bridge. So the watch post hardening strategy here is very, very strict. You have to modify the firewall rules. You know how you usually have an allow all rule for internet traffic?
Sure.
You have to change the scope of that rule. So instead of applying to all adapters, you set it to apply only to the specific name of your VPN adapter.
Oh, that's granular. So the firewall literally ignores traffic unless it's coming through that tunnel.
Correct. And then, and this is the step people forget, you enable a rule right below it that says block all other traffic. You are effectively cutting that second cable.
You're isolating it.
You're isolating the machine so it can only speak through the secure tunnel.
Now, here's a nuance I caught that confused me at first. In the public scenario, we said block NetBIOS immediately. But the notes say for the VPN scenario, you should not enable NetBIOS protection. Why the contradiction?
Because context matters. Once you're inside that VPN tunnel, you're technically part of the corporate network again. You might actually need to access that shared drive or that printer server back at HQ. And those things use NetBIOS.
So if you block it.
If you block NetBIOS inside the VPN profile, you break the very functionality that the VPN was built for. It's a balancing act.
Trust the tunnel, but untrust the room you're sitting in.
Exactly.
All right, scenario 3, the easy one. The corporate user. I am physically in the office, plugged into the wall.
This is your low-risk profile.
Wow.
Standard firewall policies, file and printer sharing are allowed because, we trust the network, but there is an efficiency play here.
The bandwidth issue.
Huge issue. Imagine it's Patch Tuesday, a massive 500 megabyte update comes out. If you have 500 people in the office...
And they all try to download it at once.
From the internet at the same time, your internet connection just melts.
And the network team comes screaming to your desk.
So in the corporate location policy, you change the update source. You force the clients to download from the internal management server or something called a group update provider.
Which is basically just another computer acting as a local distributor, right?
Yeah, it's a designated courier. One machine downloads the update, passes it to its neighbors, saves a massive amount of external bandwidth.
Okay, one final detail on the corporate side wireless. The notes mentioned 802.1x.
Right. If your office uses that enterprise-grade security, the kind where you log in with your username and password, not just a shared Wi-Fi key, that uses a protocol called EAPL. You have to make sure your firewall allows EAPL traffic. If you forget that rule, the laptop can't authenticate.
This just gets kicked off the Wi-Fi.
Immediately. It's a common ticket.
But
My firewall is so secure, I can't even get online.
okay, so we have our three skins. Public is body armor, VPN is tunnel vision, corporate is business casual. But the real magic is how the laptop knows which skin to wear.
The brain, the logic engine. It's not just guessing, it is actually running a scoring system, almost like a game show.
It really is.
It's a point-based system. Every time the network state changes, you plug in a cable, you wake from sleep, the client runs down a checklist for every possible location you've configured.
So walk us through the math. How does it decide who wins?
Okay, let's say you have a location called Office. The client checks the criteria you set. If the conditions match, like it can see the management server, it awards that location plus 15 points.
And if it doesn't match?
Minus 15 points.
Harsh.
It's binary. Now, if you have a location with no specific conditions, like that default catch-all we talked about, that gets 0 points.
So it just does the math and the high score wins.
High score wins, the client switches to that location.
But what about rebooting? If I'm at the office and I restart my computer, does it have to do this whole calculation from scratch? Seems slow.
Not necessarily. There's a setting, remember last location. If you check that box, the device boots up, assuming it's in the same place. The system gives that location a plus 10-point head start.
A bonus for incumbency.
Exactly. It prevents flapping, where the system can't decide. But if that fails, it defaults to, well, the default, which is why your default needs to be body armor mode.
Right.
You do not want it defaulting to open access at the airport just because a calculation failed.
So what are the detectives? What clues is the software looking for to award these points?
It looks for a few things. First, connection to the management server. Can I talk to the mothership?
Right.
Second, network connection type. Am I on a VPN adapter? An Ethernet card? A wireless card? It can even look for specific files or registry keys. But the most powerful and the most controversial trigger is DNS.
This was a huge section of the Wash Post guide. DNS as a trigger.
It's clever. Basically, you set up a rule that says, try to resolve this specific internal host name, like intranet.company.com.
And if I'm at Starbucks, that lookup fails.
Exactly. The Starbucks DNS server has no idea what that is. But if you're in the office, the internal DNS server replies with a specific internal IP.
If the client sees that IP, it goes bingo. I'm inside.
It's a secret handshake. But this leads us to the reverse DNS controversy.
I saw this, a reverse DNS lookup. Symantec disables this by default, but some admins want to turn it on. What's the difference?
Okay, so normal DNS is, here's a name, give me the IP. Reverse DNS is, here is an IP address, tell me the name.
And why would a firewall need that?
Well, it sounds useful. Instead of blocking 1,000 weird IP addresses, you could just say block anything from badhacker-site.com.
That does sound great. So why is it disabled?
2 reasons. First, performance. Every single connection requires a lookup. If your DNS server is slow, your entire computer feels like it's walking through mud.
And nobody wants a slow computer.
No. But the second reason is security. DNS is not always trustworthy. An attacker can spoof DNS responses.
They can lie about who they are.
Exactly. So relying on the name is actually less secure than relying on the raw IP address. The watch post recommendation. Keep it off. Trust the IPs, not the names.
And speaking of trust, I saw a warning in the forums about a specific bug in version 14.2.
Ah, the 14.2 bug. A classic cautionary tale. Apparently, in that version, location switching would completely fail if you relied only on DNS lookup triggers.
It would just get stuck.
It would get stuck. It highlights a golden rule. Never rely on a single point of failure. Use DNS plus management server connection plus an IP range. Triangulate.
Okay, we have time for one more headache. Slapping.
The bane of my existence.
This is when the computer just can't make up its mind, right?
Right. Picture this. You're at your desk. You dock your laptop, so you're on Ethernet. but you forgot to turn off your Wi-Fi.
I do this literally every single day.
Most people do. The problem is now your computer matches the criteria for Office Ethernet and Office Wireless.
So they both score plus 15 points.
Exactly. And the computer freaks out, it switches to Ethernet, then checks again, switches to wireless, and checks again. And your connection drops every 30 seconds.
How do we stop the madness?
You have to use negative criteria. You have to teach the logic engine to be exclusive.
Give me an example of what that rule looks like.
So for your Office wireless location rule, you don't just say is connected to wireless. You change it to say is connected to wireless, and D is not connected to Ethernet.
Ah, so the Ethernet connection acts as a veto.
Exactly. If the cable is plugged in, the wireless profile is disqualified immediately. The flapping stops.
That's satisfyingly logical. Now, before we wrap, what about the poor admin who has to fix this when it all goes wrong? The sources listed a few black box recorders.
Right. If you're really in the weeds, you need a tool called Debug View. It lets you see the raw code strings the software is spitting out. You're looking for query contents of data.
Query contents of data. Sounds like something from the Matrix.
It feels like it, but for a slightly higher level view, check the sylink.log. That's the communication log between the client and the server. If the policy isn't downloading, or if the green dot on the yellow shield icon disappears.
The yellow shield in the system tray.
Right, that icon is your best friend. Green dot means I am talking to the server. No green dot means you have a communication break. The sylink log will tell you why.
So, bringing this all back, we've gone from the coffee shop to the VPN to the office. We've blocked ports, we've split tunnels, debugged the logic engine.
It's a lot of moving parts.
It is.
Yeah.
But if you had to boil it down, the key takeaway for me seems to be that default setting.
It has to be. If you take nothing else away from this deep dive, security cannot be static. If you have a static policy, you're either blocking your users from working or you're leaving them wide open. And when in doubt,
Default to the armor.
default to the armor.
I want to leave you with one final thought. We've spent all this time talking about server control, how the IT admin sets these rules to protect the user. But the troubleshooting guides, they touched on client control. The ability for the user to just right-click and say, disable firewall.
The ultimate tension.
We build these incredibly complex logic engines, we score points, we define negative criteria. But is the biggest risk to the network actually just the well-meaning employee who turns off the firewall because they want to print a boarding pass at home?
That is the nightmare. You can automate the security, but you can't automate the user. If you give them the keys to the castle, they might just leave the drawbridge down because it's more convenient.
A terrifying thought to end on. Secure your perimeter wherever it is, and maybe don't give your users the disable button.
Words to live by.
Thanks for listening to The Deep Dive. We'll catch you next time.